Alright, good people, this is section 1.6, Rational Expressions. Before we get started, I just wanted to remind you, as always, that if you have any questions, I want you to write them down right there. In fact, not if you have any questions, when you have questions, because this is tough stuff, and if you don't have any questions, that means you're not thinking about it. So think about it, and if there's anything that needs further explanation or just seems a little fuzzy to you, for whatever reason, and if you don't feel like texting your friends or Googling it or emailing me, then just go ahead, write your questions right there. Then we also have audio check. I just want to make sure that you're listening, because I've had students in the past, not any of you guys, obviously, but I've had students in the past who've decided to just watch instead of listen, and I think listening is very important, so I'm going to drop some personal information, and I want you to write it right there when I do. Rational expressions, here we go. So what's a rational expression? Rational, when we say rational in math, it means resembling a ratio. It's like, like a ratio, or resembling a fraction. A ratio is just another word for fraction. So really, these rational expressions are expressions that can be said expressed in the form of fractions. Lots of fraction bars everywhere. One thing I want to remind you of is that if you try and take 8 divided by 0, that's actually undefined. I mean, there are lots of... Division is really well defined in a lot of ways, like 8 divided by, that's a terrible division sign. 8 divided by 4 is defined as 2. 8 divided by 1 is defined as 8. 8 divided by 8 is defined as 1. But 8 divided by 0 has no answer. It's undefined. So, and that's different from saying, it's not like I'm trying to say that the answer is actually 0. 0 divided by 8 is defined as 0. That's fine. This is a well-defined answer, but 8 divided by 0 is undefined. So we say that 8 divided by x is meaningful only when, or is not meaningful. 8 divided by x is not meaningful when x is equal to 0. So meaningful, meaning it has a well-defined answer. Determining the meaningful replacements. Okay, so, and this book is kind of strange in its use of vocabulary, because I've never really seen the word replacement before. Usually it's called substitutions. To determine the meaningful substitutions. What values can you put in here for x and it all still work? Well, you can't put in x equals 5. X should not equal 5. So what are the meaningful... Because what happens when you do put in 5? If you put in 5, it becomes 5 minus 5, which is 0. You can't have anything divided by 0. So we say that the meaningful replacements are the set of all x such that x is not equal to 5. Like, let's say this is all real numbers except 5. Is meaningful everywhere except 5. Where is this going to be meaningful? We don't know yet. So let's factor it. When will x squared plus 7x plus 12 equal 0? Factor x. What two numbers times each other equal 12 and add up to 7? That'd be 3 and 4, so you get x plus 3 and x plus 4 equals 0. Therefore, x plus 3 equals 0, or x plus 4 equals 0. So whenever x is equal to negative 3, or x is equal to negative 4, then the denominator is going to equal 0, which we can't have. So the meaningful replacements will be all numbers except for negative 3 and negative 4. Every other number is a meaningful replacement. All numbers x such that x is not equal to negative 3, or x is not equal to negative 4. So you can put in any number in for x that you want, just make sure it's not negative 3 or not negative 4. Simplify. Alright. So if we had a fraction that was, say, 10 over 3 times 24 over 5, you could simplify it like this. 1, 2, 3 goes into 24 8 times. And so 2 times 8 is 16 over 1, or just 16. We're going to do the same thing here. We're going to factor both fractions, and then we're going to cancel stuff out. So it looks like I can factor the denominator, the first denominator. This becomes... Wait a minute, no, I can't factor the denominator. It's not a difference of squares. Or if I tried to, I wouldn't be able to cancel anything out. So I'm just going to multiply these two together. I'm going to say that the answer is x plus y squared times 2x squared minus 1 times 7x. I've simplified it, not going to be able to simplify it any further. Here, if we were dividing fractions, I just want to remind you that dividing is the same thing as multiplying by the reciprocal. So we can say that this is going to be x minus 2 over x plus 2 times, flip it, the reciprocal would be 4. And this reciprocal would be x plus 2. And since we can't cancel anything, I'm just going to turn this into one big fraction, and that's our answer. For number 5, one thing I'm just going to note is that you can cancel out here these and just say that the answer is x plus 2 over x minus 5. However, one thing you have to note is that x is still all numbers such that x is not equal to 5. Like, you can't put 5 here. That's fine. But also, you can't put x is equal to negative 3. Neither 5 nor negative 3 will work in the original. So you have to make sure that if they want to know what meaningful replacements you can have, you have to exclude 5 and you have to exclude negative 3. But all the other numbers should work. Now, I want to caution you, I want you to cancel only the factors separated by multiplication. Don't cancel the terms separated by addition. So what I've seen students do is I've seen them mistakenly do these kinds of cancellations. I've seen them mistakenly say, oh, I see a 2 and a 2, therefore I'm going to cancel it. And maybe they write 6 as the answer. Well, if you do 6 plus 2, that's actually equal to 8. And 8 over 2 is actually equal to 4. 4 is the real answer. If you do canceling in this way, then you're going to get the wrong answer. So I would say don't cancel terms separated by addition, cancel terms separated by multiplication. Cancel terms separated by multiplication. Let me show you what I mean. If you were to cancel out the 4x right now, that would be wrong. What you have to do is you have to factor. So you get, finding the greatest common factor in the numerator is going to be 2x. 2x times what is 6x squared? That would be 3x, and plus 2. And then factoring out the greatest common factor at the bottom, that's also 2x. That's going to be x plus 2. Now these factors are separated by multiplication, so I can cancel these out. And I'm just left with 3x plus 2 over x plus 2. That's the answer. 7. Let's factor both the top and the bottom. I'm going to need to factor x up here. What two numbers multiply up to 2 and add up to 3? That'd be 1 and 2. And I see a difference of squares here. That would be here. I'm going to let a equal y and b equal 1, so we've got a squared minus b squared, which I know is the same thing as a plus b and a minus b. So, changing all that, the big fraction is going to be, from here, we're going to get y plus 1, y plus 2. And then a plus b, a minus b, that's going to be y plus 1, y minus 1. What cancels? These terms. And notice they're separated by multiplication. When the factors are separated by multiplication, then you can cancel them out. And the answer is just going to be y plus 2 over y minus 1. Now might be a good time for me to drop some personal information. Hey, did you know where I met my wife? I met my wife in high school. I was a senior, and she was a junior, and we started dating each other because we got to know each other through High School Musical, and I'd love to, not the movie, but an actual high school musical that we were both in. So, yeah, let's talk more about it in class after you finish your assignment. All right, let's factor. Looks like over here, just to make the video a bit shorter, I'm going to do some of the factoring in my head. I hope you don't mind. We get x minus y squared, x plus y, 3x plus y, and x plus y, x minus y. Check this out. I love canceling. We're going to multiply all these terms. We've got lots of factors here that we can cancel out. So I see a x plus y here, and an x plus y here. And I see an x minus y here, and only one left. So I'm going to say that the answer is 3x minus y over x plus y. Number 9. Oh, look at that. Some division. Alright. Let there be no division among us. Actually, I love division. Check that out. Alright, so we're going to change division to the multiplication of the reciprocal. And so that means I'm going to put the 2a squared b squared up top. That's an actual formula that we have memorized. If you don't have it memorized, then let's keep on practice using it, and that'll help you memorize it. A minus b. Actually, the formula says that it should be squared, so I'm going to write in squared. And then ab, if you want to factor the difference of squares up top, it's just going to be a plus b and a minus b. Okay, so what cancels? I see an A, cancel that. I see a B, cancel that. Oh, canceling is fun. Just love crossing stuff out. Yes, 1. So what are we left with? A plus B over A minus B. And don't forget the 2AB up top. 2AB from here. So this is the answer. Next page. Alright, let's rock this thing. Let's go. Let's factor this. Yikes, so much factoring we've got to do. Alright, we can do this. We've got x plus y on the top, and that factors into x squared minus xy plus y squared. Factoring the denominator, we get x plus y, x minus y, times. Let's flip these. Take the reciprocal. We're going to put x squared minus xy plus y squared. And factoring the top, we get x minus y squared. Let's do some canceling. Oh, this is my favorite part. Look at this big bad boy that cancels. Whoa! So much canceling. The carnage! Oh, there's nothing left except x minus y. Do you mean to tell me that all that just turns into x minus y? Yes. Alright. Number 11. Oh, look at these two fractions. They've got common denominators. That means I can add them together. So we get x minus 5. Just like if you had 1/3 plus 2/3, you can add them together to get 3/3. That's why these combine. They are common denominators. So adding these like terms, we get 3x squared. And then 5x minus x is 4x. Minus 9 is 11. You get plus 2. I could see them saying that you need to factor the top as well to maybe cancel out with x minus 5, but the x minus 5 isn't going to be one of the binomials that factors that term, so since I know I can't cancel out an x minus 5 from the numerator and denominator, I'm just going to say that that is finished. Here we don't have a common denominator, so we need to find the least common denominator. The least common denominator would probably be x minus 5, because what I can do is I can multiply this whole thing times -1. Whatever you do to the bottom, you have to do at the top. -1 and -1. That would be x minus 5. 3x squared plus 4. Distributing -1 to the entire numerator, you get -x squared plus 7. Now that we have common denominators, we can add. Get x minus 5, and 3x squared minus x squared is 2x squared. 4 and 7 is going to be 11. And again, because I'm quite sure that we're not going to be able to cancel out an x minus 5 from both numerator and denominator, we can say that we're finished. Here we go. Now here we go. Let's factor this big bad boy. Let's see what happens. So we've got, in the top, this looks like a perfect square. In fact, if I had a is equal to x and b is equal to 2y, then this would be 2ab. So this is going to be x minus 2y squared. Let me do a little bit more of that out so you can see it. 2ab, that would be 2 times x times 2y, which is 4xy, which is what we have. So using the formula a squared minus 2ab plus b squared, we substitute to get a minus b squared down here. Alright, down below, let's factor this. Alright, so you can see that a is equal to 2, and b is equal to -3, and c is equal to 1. I'm going to use bottoms up. So b is equal to -3, and a times c is going to be 2. So what's two numbers multiplied to 2 and get -3? That would be 1 and to actually negative 1 and negative 2. Negative 1 times negative 2 is 2, positive 2, and negative 1 plus negative 2 is negative 3. So that means I can write, we can write x minus 1y and x minus 2y. Because it's bottoms up, we're going to take the a value and put it over here, over 2, over 2. This cancels, and this goes up here, so we have 2x minus 1y and x minus 1y. When I recopy it over here, it's just going to be without the 1's. So we have 2x minus y and x minus y. Plus, let's factor the top, x plus 4y over, factor out the bottom, we get x minus y. So here, we have to figure out what the least common denominator would be. Least common denominator, I think, is going to be, we have this term, or this factor, this factor, this factor, and this one, this factor is already repeated. So I think what we need is we need 2x minus y, x minus y. So of these four factors here, one of them gets repeated. So we'll take the 3 that are not repeated over here. That's the least common denominator. The least common denominator, 2 times 2x minus y and x minus y. What do you need to do in order to get to these fractions? What do you need to multiply by? Well, for the first fraction, you need to multiply by 2. Multiply the denominator. We multiply the denominator by 2, so we need to multiply also the numerator by 2. X minus 2y squared. And what do we need to multiply the denominator by in the second fraction? The second fraction needs an additional 2x minus y in the denominator, so I will also apply that to the numerator, 2x minus y. So now we have x plus 4y times 2x minus y. And now that we have common denominators, we can add the two fractions. 2 times 2x minus y, x minus y. Foiling the top and combining like terms is actually a kind of a lengthy process, and I hope that we can do that now. So I'll just skip forward to the end and say that this is 4x squared minus xy plus 4y squared. Should be able to FOIL, combine like terms, and then add these two numerators together to get this, and that's the answer. And you know what? I'm not going to say that we need to do 15 and 16 because this video is just getting too long already. So here's what I'm going to do with number 14. We're going to do most of it, and then I'll ask you to finish it. Factoring this denominator. The first denominator has a factor x of, let's see, 11 and 30. So that'd be 6 and 5. 6 times 5 is 30, 6 plus 5 is 11. So x over x plus 6, x plus 5. Let's factor the top here, factor the denominator here. This factor x will be 9 and 20. Let's see, 5 times 4 is 25, plus 4 is 9. So we get x plus 5, x plus 4. We need a common denominator. I also need to kind of separate these two problems. The common denominator, I'm pretty sure, is going to have to be x plus 6, x plus 5, x plus 4. X plus 6, x plus 5, x plus 4. Now, what do we need to multiply both the numerator and the denominator to go from that fraction to that fraction? We would need to multiply both the top and the bottom by x plus 6. And what do you need to multiply both the denominator and the numerator by to get from that fraction to that fraction? You need to multiply it by x plus 4. Combining both fractions together, we get x squared plus 4x, that's distributing, minus, distributing here, we get 5x minus 5x and minus 30. And in the bottom, we've got x plus 6, x plus 5, x plus 4. And I want you to tell me, there's one last step, and I want you to combine the like terms in the numerator and tell me what the answer would be. It's a fraction. You tell me what it is. Once you figure out what it is, then go ahead and write it down. Also, start working on assignment 1F. Do the first problem in your assignment book. I'll see you in class.